Today we're going to practice simplifying radicals. So this may look familiar to you already, at least some of it might. So for our first example, we have the square root of 16a to the 8th. Now if you remember what a square root represents, it's what number times itself. Oops, wrong pen. It's what times itself will give us 16a to the 8th. Okay, so we have to think of this in two parts. We're going to think what number times itself gives us 16 and what times itself gives us a to the 8th. Well, 16 we can do. What is the square root of 16? I'm sure some of you guys have been saying 4. But to do the square root of a to the 8th, I want you just for a minute to visualize you have 8 a's that are being multiplied. 7, 8. We're doing the square root. Our index is 2. Okay? So I'm going to group them according to my index. 2 a's here, 2 a's there, 2, and 2. So I can think of the square root, I'm just going to rewrite this part, of a to the 8th as really the square root of a squared 4 times. Okay? Well, what's the square root of something squared? What would be the square root of 4 squared? We know 4 squared is 16. The square root of 16 is 4. When your power, that 2, is the same as your index, you're taking the square root of something squared. Those are inverse operations. So the square root of this first a squared is just a. The square root of this a squared is a. This one is also a. This one's also a. You end up with a to the 4th. Our final answer is 4 times a to the 4th. Okay, now you may have realized, or maybe you see this, maybe you don't. But if my index is 2, how many times does 2 go into 8 evenly? 4. That's always going to be the number of times that's going to come out of a square root or a cube root or whatever root you're doing. So it's a little tip to kind of help. All right, let's take a look at our next example. Notice here we're doing the cube root. So you got to know, or you're looking for what times itself 3 times will give us 12 a's and 6 b's multiplied together. So if you have 12 a's, think of how many times if out of 12 a's, how many different groups can I make if I put 3 a's in a group? Or think how many times does 3 go into 12 evenly? The number of times it goes in there evenly is what's going out of the root, a to the 4th. So now you're going to do the cube root of b to the 6th. How many times does 3 go into 6 evenly? Or if you have 6 b's, how many groups can I make if I have 3 in a group? You can make 2 of them. And you can feel free to check that. A to the 4th b squared times a to the 4th b squared times another a to the 4th b squared. I end up with 4 a's, 8 a's, 12 a's, all being multiplied together. 2 b's times another 2 b's times another 2 b's. 2, 4, 6, that gives me 6 b's that are multiplied. So I know my answer is correct. Okay, our next example, we're back to cube roots. So we're going to take the cube root of each of these factors. And I didn't write this out for the last one, but you can write it out like this for any of them. Because these are products, you can break apart a product into any of its factors. Okay, the cube root of negative 125. Well, what number times itself 3 times gives you negative 125? That's a perfect cube. You should be thinking negative 5. Okay. Now, the next factor, the cube root of x cubed. How many groups can you make if you have 3 x's in a group? You can only make one group. The cube root of x cubed is just x to the first. So we're going to put an x down there. Next one, you have the cube root of 21, or y to the 21st power. If you have 21 y's written out, and you put 3, you're making groups, and there's 3 y's in each group. How many groups can you make? That's the same thing as 21 divided by 3. You can make 7. And for the last one, you have 10 z's. And again, you're putting them in a group. But notice this time, you don't have an even number in a group. You can have these 3. There's one group. There's another group. So you can have 3 groups. 3 goes into 10 evenly 3 times. So that's going to be z to the 3rd. But you have this one lone remainder out there. That remainder, that lonely z, that needs to stay under the cube root. If it does not have a group to go in, it stays under the cube root. Okay, and of course, do not forget to put your index. And also make sure that you leave spacing in between the last factor and the radical. Okay, we don't want to bunch everything up. There should be plenty of space on your work. So our final answer is -5, x to the 1st, y to the 7th, z cubed, times the cube root of z. All right, well, let's take a look at our next example. This one is a little different in some ways. So now I'm back to square roots. My index is 2. Oops. Let me fix that. Grab the pen. And a lot of times we don't write the square root. It's just implied. And you still have a product here. So I'm going to really do the square root of each of those factors. Okay. What number times itself 2 times gives you 36? Well, we know that's to be 6. But then for the second one, when you have the square root of a quantity x minus 5 squared, well, what times itself 2 times will give you x minus 5 times itself squared. That square root and this to the second power are inverses. They undo each other. You are left with just x minus 5. Or you can think about 2. How many times does 2 go into this 2? 1 time. So you can pull out one group from that square root. We can actually leave this as is in factored form, or if you really want to, you can distribute. I'm perfectly fine with either answer. Okay. But that x minus 5 to the second power is no different than when it was like a squared or b squared, okay? Okay, our next example, here we notice that we have a 5 outside of the radical. So this is 5 times the cube root of 27, m squared, n to the 6th. So we don't have to do anything with that 5. Whatever comes out of the radical, it'll be multiplied by the 5, since it's all in terms of multiplication. So I'm going to do 5, and I'm going to do the cube root of each of these. 5 times the cube root of 27, the cube root of m squared, and the cube root of n to the 6th. Okay. Well, the cube root of 27, so what number times itself 3 times will give you 27? I'm sure you're all thinking 3. Because 3 times 3 times 3. That 5 that's out there, that's just going to hang down. It's going to eventually be multiplied by the 3 that we're able to simplify from the radical. Now, next factor, we have the cube root of m squared. Well, think about your groups again. If you have an m times m, Can you make a group of 3 m's together? No, you can't. So it turns out that the m squared is going to stay underneath the radical. Okay? Anytime your index is larger than your exponent underneath the radical, you can't reduce that. So that's just going to stay as is. And then let's go to the next factor. We have the cube root of n to the 6th. So you have 6 n's all being multiplied. How many groups can you make if you put 3 in a group? In other words, what is 6 divided by 3? 2. So you get n squared. And then that, I'm going to write my radical last. Okay, I'm going to multiply all these together. Those are now my coefficients of my radical. So I have 15 n squared times the cube root of m squared. Do not forget that root, that index I mean, and make sure again you left a little bit of space there. All right, let's try another example. Notice here we also have a coefficient. It's in front of a square root. So I have 3 different products underneath this root. I'm going to take the square root of 8, the square root of 2x plus 1, and that's to the 4th power, and the square root of y to the 8th. Okay. All right, now what number times itself will give you 8? There is none. 4 times 4 is 16. 2 times 2 is 4. 3 times 3 is 9. There is no number times itself. But we can break 8 down, and we've already done this. 8 has a factor that is a perfect square, 4. So we have the square root of 4 times 2. The square root of 4 is 2, and this 2 is going to stay underneath the radical. And I should back up and add that this negative 3 is just going to be multiplied down here below. For our next factor, we have the square root of 2x plus 1 to the 4th. So again, you have 4 2x plus 1s, all being multiplied together in a row. You're making them in groups of 2. How many times does 2 go into 4 evenly? Twice. And we're just going to leave it in parentheses. Okay? And finally, for our last one, we have 8y's. And we're doing the square root of them. So what times itself gives you 8y's, or y to the 8th? 2 goes into 8 evenly 4 times. You could think of it again as if you have 8y's, how many groups can you make if you have put 2 y's in a group? You can make 4 of them. Okay. So, and of course we still have this square root, and we're going to put that at the end. Anything left in the square root is going to be moved to the end. We're going to multiply all of these together, and we get negative 6 times 2x plus 1 squared times y to the 4th times the square root of 2. And that's our final answer.